Hello everyone, today we're going to take a look at Unit 6, Lesson 7, Sine Law. So we're going to take a look at this triangle to get started, and it's asking us to solve for side A. So side A would be here across from angle A. So if we took a look at considering using our primary trig ratios, remember we need a 90-degree angle or a right angle to use those primary trig ratios. So this triangle does not have a 90-degree corner. So if that's the case, if there's no 90-degree angle, we cannot use those primary trig ratios. Remember, we only use them for a right triangle. So therefore, we cannot use the primary trig ratios. Remember, the acronym we use to remember those is SOHCAHTOA. And we have two side lengths, so we maybe could think about with triangles, oh, maybe I can use Pythagorean theorem. But again, Pythagorean theorem has to have a 90-degree angle, so we can't use primary trig ratios, or we can't use Pythagorean theorem. So this is where our sine law comes into play. Sine law is something that we use in mathematics when we don't have a right triangle. So when we have what we call an oblique triangle, basically a non-right triangle. So if you look at the triangle below, if we have a triangle with angles A, B, C, and then we have their corresponding side lengths, A, B, C, the sine law basically says that the ratio of side angle pairs are going to be equal. So we're going to write that down and then we'll talk about that means. So the ratio of side angle pairs are equal. So what do I mean by a side angle pair? Well, angle B and side B create a pair, basically. They create this side angle pair. We can see that A and A, that's a side angle pair. That's why we use the capital letter and the lowercase letter for those sides and angle, because they relate in this way. Okay, and then C has this side angle pair. So think of these as a side angle pair. Okay. And our sine law basically says that the ratio, which we're writing as a fraction, okay, the ratio of that side angle pair is going to be equal to all the other ratios of the side angle pair. So if we were looking at the ratio of the sine of angle A over side length A, that's going to be equal to the ratio of the sine of angle B over side length B, okay, and then continued on with side C as well. So all of these are going to equal each other. And the reason that we have two of them is we use one setup if we're trying to solve for an angle, and we use a different setup if we're trying to find a side. We always want to put the unknown value on top. It just makes the algebra a little bit easier. So you can see for our first sine law here, our angle part is on top. So if solving for an angle, we're going to use this one. And the one on the bottom is if we're solving for a side. Okay, we're going to use this one down here. Okay, so we're going to revisit that first example and see if we can solve for side A. So I'm again going to label side A. Okay, and then when I'm trying to set up my sine law, I like to circle what side angle pairs do I have to work with. So I know I'm trying to find side A, so I need to work with this side angle pair. And then the other side angle pair, I need to have both pieces of information. So you can see if I were to, let's label this side C as well. Okay, I have both pieces of information for my side angle pair for C. That's not true for B, right? I don't have angle B, so that side angle pair, I don't have enough information. This brings up another point. We only ever use two ratios at a time. So only use two ratios at a time. And because we're trying to find side A, we're going to use the setup for solving for a side. Okay, so I'm going to write my sine law for these two ratios. So I'm going to set up with my sine on top. So we're going to have A over the sine of A. And because we're using our side angle pair with C, that's going to be equal to C over the sine of C. Okay, and then we'll just sub in what we know and we'll walk through the cross multiplication. So we'll have A over the sine of angle A is 35 degrees. That's going to be equal to C, which is 7 meters, over the sine of angle C, which is 65 degrees. Okay, the reason that we always set up with our unknown on top is because then our cross multiplication is a little bit less. We just need to multiply the sine of 35 over, right? We don't need to multiply the A over to the other side because then we're just making an extra step for ourselves. We want to isolate A. So if we multiply that sine of 35 up to the top here, and then divide that by the sine of 65 degrees. And you should be able to put that calculation in your calculator all at once. And when you do, you should get the A is equal to 4.4 meters. Play around with your calculator and make sure that you're able to plug this last step in all at one time. Calculators are different in terms of when you hit the sine button versus the angle. So you just have to make sure you're comfortable using your calculator. And we'll probably practice this actually in class. Let's look at a few more questions. Okay, so example 2 says find the value of n if angle P is 64 degrees and angle N is 38 degrees and side M is 20. So again, we need to figure out what side angle pairs we have here. We know we're working with a side angle pair for N. But then if we notice, we don't have P, okay, and we don't have angle M. So I don't have a side angle pair where I have enough information. We have to think about, is there some information I can find before getting to that sine law? Well, I can find angle M because I know the sum of my interior angles is 180 degrees. So let's find angle M. All we're going to do is subtract the sum of the angles we do have from 180. So we know that angle P is 64 degrees, and we know angle N is 38 degrees. So if we add them together and subtract from 180, we should find the angle M is 78 degrees. I'm just going to write that in here. Okay, now we have this side angle pair we can use to set up our sine law. So I'm going to write that the n over the sine of n, okay, because that's the first side angle pair, is going to be equal to, I'm going to label this with a lowercase m, going to equal m over the sine of m. Okay, so we'll fill in our values here. N over the sine of 38 degrees is going to equal m is 20 over the sine of m, which is 78 degrees. Okay, I'm going to again multiply that sine of 38. So we'll have n equals 20 times the sine of 38 degrees all over the sine of 78 degrees. And when you put that all into your calculator, you should get that side length n is going to be 12.6. Okay, so we still set up solving for a side. The next question, we're going to take a look at solving for an angle. Okay, so find angle D. So in this question, we're trying to find angle D. So we know we have to work with this side angle pair. And then the side angle pair we have to work with along with D would be for F. So this time, because we're trying to find an angle, we're going to set up to solve for an angle, which means the sine part is going to go on top. So we are trying to find the sine of D, okay, over the side length D, which is going to equal the sine of F over side length F. Okay, so side length D is 14, and then the sine of angle F is 47 degrees over side length F is 12. And again, I'm going to multiply just that part up here as we try to isolate angle D. So if you calculate everything in this fraction, you should get, and as I mentioned in a previous note, we want to leave at least 4 decimal places. Okay, until we get our final answer. So we saw this when we were solving for an angle with our primary trig ratios. We need to isolate D, so we're going to have to do the sine inverse to isolate D. So we'll have the sine inverse of everything inside this bracket, 0.8532. I'm just going to call that angle D, and you should find that angle D is equal to 58.6 degrees. So similar to when you're finding the side length of a triangle, but when you're finding the angle, there's that extra step of doing the inverse, sine inverse, to find your angle. Okay, the last one is asking us to solve for the entire triangle. So remember, that means we're going to find all the unknown sides and all the unknown angles. So you have to determine kind of what do I have enough information to start with. So if we take a look here at triangle PQR, well, I have a side angle pair with P, and then I have some information about side Q. So I'm going to use that to help me find angle Q to get started. So let's find angle Q. So remember, we're going to have to do the setup for finding an angle. So we'll have the sine of Q over Q is equal to the sine of P over P. So side length Q is 9. And then the sine of P, well, angle P is 45 degrees over the side length of P, which is 7. So I'm going to multiply that 9 up. And then once I calculate what's on the right-hand side, I can take the sine inverse of that. So everything in that fraction from the previous step is going to be 0.9091. And then we should find that angle Q is equal to 65.4 degrees. Okay, as we work through these in class, I'll make sure that you guys are putting these in on your calculator and able to get those calculations. Once we have angle Q, we should be able to then find angle R. So we found that this is 65.4 degrees. Now I have 2 angles in my triangle, so we should be able to find that third angle by subtracting from 180. So we're going to find angle R. Oops, let me write that again. We know that R, angle R, is going to be equal to 180 minus the sum of the other 2 angles. So 45 plus 65.4. So that will equal 69.6 degrees. Okay, so I could even write that 69.6 degrees in here. Now the only thing left to find would be side length r. So this was r. Now we have to find, okay, what's r? That's our side angle pair there. That's the only unknown left. Okay, so when we set this up, we're going to set it up with our side on top of our ratio. So we're going to have r over the sine of r. And then I would advise that when you're picking, well, now I have lots of information, which ratio should I use with r? Use the ratio that was given to you. In case you made a calculation error on the other ratio, just always use the ratio that was provided to you in the question if possible. So we were given all the information for p. So we'll use p over the sine of p. So angle r is 69.6 degrees equals p, which is 7, over the sine of p, which is 45 degrees. And we're going to multiply that sine of 69.6 up to the top. So r is going to end up equaling 9.3 centimeters. Okay, so wrapping up our sine law, really our sine law is used when we don't have a right triangle, and we can use it to find unknown angles or unknown side lengths. That's all for your note for today.